For this tutorial, we'll be looking at the hydrology spatial analyst tools to conduct a hydrology analysis on our watershed. The first step is to add our DEM watershed data. Next, we'll open up our toolbox, go down to our spatial analyst tools, and then to hydrology. Our first step is to fill this raster data in order to make sure that all the data is as even as possible when we begin to conduct our analysis. So I'm going to select the DEM, save it, call it DEM underscore fill 2, hit OK, and then we'll get a DEM that really doesn't look anything different than what our original one was. The second step in this process is to then do a flow direction analysis. We'll click our fill layer. We'll then save it. Call it DEM dir 2. Hit save. Leave all this the same. Hit OK. Now what we've been given is a raster file representative cells colored based on this order. And each one of these represents a different direction. So 1 represents to the right, 2 is down right, 4 is down, 8 is down left, 16 pointing to the left, and then so forth as you go around. We are able to actually convert these into points, which then we could use to convert to arrows, so that way we can see when we zoom in close exactly the direction that water is moving along the surface of our DEM model. So to do this, we will go to our search tool. If you don't see it here, it will be in the top bar. Type into the search command point to raster, hit search, and then select the raster to point conversion here. Opening this, we then will select our DEM dir 2, and for this we will want value as our field, the field that we want to kind of assign to each point. Then here we will type in point dir 2. Hit save. Then I'm going to hit OK. Now what has happened is that all of these points have been every single one of the cells has been converted to a point with this data associated with it. So I'm going to turn that off, turn this off, open up my attributes table, and we'll be able to see that right here in our grid code is that data. So I'm going to close this, right click, go to properties, open up my symbology tab, send categories, unique values. I'm going to then get my grid count, hit add all values. So I'm going to hit OK. So now what we have is we have a list of all the points, and now we can change each one of the symbology in order to match the direction that they're going. So when we double click, we can then go and try to find our arrow feature. Some arrows are located within the public sign style reference tab, so I'm just going to click OK. Scroll all the way down till we get here, and here we can see our arrows. So for 1, it's to the right, so I'm going to hit OK. For 2, it's down and to the right. 4, oops, it's down, and so forth. So continue to do this until all your arrows have been attached. Our final arrow. So now this will take, say, a little bit to render, because it's now every single one of these points is associated with an arrow. So now I can zoom in and actually see how everything is moving. And actually, I'm going to want to shrink all these, so I'm just going to change them all to a 9 and see how that works. So now if we were really interested in maybe one direction of water travel or something, we could really highlight that by having this be maybe a little bit larger as well as a different color. We can now emphasize certain directions of movement and travel within our map at a larger scale. To kind of see how all the water now is moving, where is it all moving in one direction. So I'm going to turn that off. I'm going to turn on my DEM direction. And for our final kind of analysis tool in this video, we're going to do the flow accumulation, where it will then, for each pixel, show where all that flow is coming from, like how much area is actually coming from before it gets to that point. So I'm going to double click flow accumulation, use my direction analysis. I'm going to save it, accum 02, hit OK, input weight raster, yeah, it's all fine, hit OK. And now what we see is a map showing the areas where accumulation is high. But unfortunately, the range is so great that we're not really getting very good representation of what actually is happening at a more refined scale. And so in order to kind of get a better look at actually what's happening, we're going to use what's inside the Spatial Analyst tool under inside Math Algebra, the raster calculator. I'm just going to double click this, and inside here, what we're going to do is we're going to create a log 10 of our accumulation 02. So that way it'll reduce this substantially in order to make it easier to see what's happening. So here, type in cum log, hit save, hit OK. And now what you see, if I turn off this, it's the old one, is that we have now a much more refined look. So I can actually make this much more visible, kind of get a better look at actually what's happening in our watershed through really refining doing that log 10 analysis. If we wanted to now potentially only look at things that have a higher percentage of accumulation area, we can open up our raster calculator again. And here we're going to click the accum log. Actually, start that over. We're first going to click conditional because it's going to be a conditional statement. We're going to be accum log is greater or equal than 2. So since we have 0 to 5.4, 2 will actually be the log of 2, so that'll be 200 square feet of area. And then what we want to return is the result of accum log. So here I'm going to say accum refine 2, hit save, hit OK. So now what we get is that map that begins to kind of show us more of the higher volumes of water are coming in the pass in which they're taking it to get into certain bodies of water. So we can then take this, can minimize, whoops, close this, won't be needing that anymore. I can then come over here and grab my Thornton streams. Hit OK. I can actually make this much bigger. Let's make it black. Actually, let's put it below this. So now we're able to actually begin to understand the relationship between actual water movement on the landscape to the actual stream.